Okay, now we'll talk about cubic graphs. Okay, so there are two lessons to talk about cubic graphs. So the first graph, like there are two ways. One form is called stationary point of inflection form, and the other one is called factorized form. So there will be two shapes. Okay, so stationary point of inflection form is that shape. And then factorized form will look like that. It's like roller coaster up and down. So there are two different forms. Okay, so today we're going to learn the first form, the stationary point of inflection form. This form is normally given in the question. So the question will just give you the point of inflection form. They're not going to ask you to make it into point of inflection form. Okay? So that the general form, I'll say that's just like, or the expand form. If give you general form or expand form, you go to make factorized form, not the point of inflection form. No. No, well, there will be way to make it, but like not all the general form can be made into point of inflection form. So, and we are not learning that, so it's not part of your job to make it into that form. So we don't need to worry about that. Okay. So today we're going to talk about what's a stationary point of inflection form. So do you remember what's a turning point form for quadratic? For quadratic, what's a turning point form? No, turning point form. Yep, that's the turning point form, right? So what's stationary point of inflection form for cubic is change the square into cubic. That's it. That's very easy. And what's the turning point before? Like, what's the coordinates of turning point? HK. So the stationary point of inflection, we call that point, is H comma K as well. So what's this stationary point of inflection? Is this dot. Like, it's like changing shape like that. So this point is called stationary point of inflection, and that coordinate is H comma K. Okay, that is H comma K. And then if A is positive, we got increasing shape. If A is negative, we have decreasing shape. But the stationary point of inflection is always H comma K. We have A positive increasing, A negative decreasing. And find x-y-intercept. You know how to do that. We can find that later. All right, so that's the basic idea for like a stationary point of inflection form for cubic. And now we look at this one. Okay, so this is exactly ax minus h cubed plus k form. So what's the stationary point of inflection in this question? 4, 2, minus h, so it's 4, comma 2. Is that an increasing function or decreasing function? In greater than 0, increasing function. Okay, that's the information we have. So we can sketch out the original function. So 1, 2, 3, 4, 4, comma 2. which is this point, right? And we know that's increasing shape, so it's some shape like that. Something like that. Can you see x-y intercepts? Yes, don't sketch it yet because I can delete it easily, but you can't. So this is the kind of the form, and you can see x-y intercept. So I will solve x-y intercept first. Okay, when x equals to 0, x0 equals to 2 times x, well, x is 0, so it's minus 4 to the power 3 plus 2. What's 4 to the power 3? Negative 64. Then plus 2 minus 1 to 8 plus 2. That's minus 1 to 6. So it's very it's very large negative number. That's why I can see it's very big there. I can't really label it to scale in this case. But let's have a look at what's the x-intercept. This is the y-intercept. So we make the whole equation equals to 0. So solve the whole equation equals to 0. So it's 2x. Do not expand it, okay? So if it's already in this form, do not expand it. So how to solve quadratic? You solve cubic in the same way. So we move everything to one side, like all the constant coefficient to one side. What cube equals to negative 1? Negative 1 times negative 1 times negative 1 gives you negative 1. So negative 1 cubed is negative 1. So x minus 4 must be negative 1. Okay, negative 1 times negative 1 times negative 1 equals to negative 1. And what x equals to in this case? 3. So x-intercept is actually at 3. Okay, it's actually this point here, 3, 0. And this point is 4, 2. Well, if I extend both graphs, I don't think you can sense. It's like very negative. Like intersect somewhere here. It's 0, minus 1 to 6. Yes? No, like you can draw scale brick like there, but like they won't really ask you to draw those kind of scales in actual exam. I'm just drawing an example because I only think about to give a good value on the x-intercept, not think about y. So that's why the number get really large. But they won't really ask you this kind of question. Or they normally give the scale to you already, so you can see the scales on the axis. So you don't need to worry about that. Okay, so that's the graph. And that's the graph. So we have stationary plus reflection at 4, 2, and we have x-intercept at 3, 0, and we have y-intercept at 0, negative 126. And it's a positive shape, and it's draw the graph in this way. And it's the same. All right. Now, one more. Just go for one more. Okay, for this one, before I start sketching it, what's wrong with it? Like, it's not in the standard form, so what's wrong with it? There's a negative x. So we need to do something with the negative because we don't want the negative inside that bracket. So what we will do is we need to change the form first. That's 3. I get a minus 1 out from inside, and then I keep that. Here's what I'm doing that. So take minus 1 out in the bracket, so that's minus 1 times x plus 1. then I can extend the bracket by using index law. I'll extend that bracket by using index law. So what I'll do is fx equals to 3 times minus 1 to the power 3 and x plus 1 to the power 3 and then plus 3 over 2. Index law, so a times b cubed is a cubed times b cubed. So it's minus 1 cubed times x plus 1 cubed. See that there's a times b cubed. There's a cubed times b cubed. Now I'm using this one here. So it's just something times something to the power of n is that to the power of n and times that to the power of n. So there's like minus 1 to the power of 3 times x plus 1 to the power of 3 to get rid of the negative because I want a positive x in the bracket. So minus 1 cubed is minus 3. So x plus 1 cubed plus 3 over 2. And that's in a good form now. What's the stationary point of inflection? Yeah, negative 1, 3 over 2. Positive shape or negative shape? Negative. Because of the negative 3, we have negative shape. Okay, now we sketch it. Okay, so we have negative 1 and 3 over 2. So that's the point here. And you know it's negative shape is something like that, or like it's negative is something like that. So we can see x, y intercept, but I don't know which way. Like it can be this way, or it can be this way. I can have different x, y intercept, like different positive or negative combinations. So I need to figure out the x, y intercept first before we can sketch it. So we can make f0 to make x equals to 0. Then we have 3 negative 0 minus 1 is minus 1 cubed plus 3 over 2. That's minus 3 plus 3 over 2. That's a minus 6 over 2, so it's minus 3 over 2. So we have 0 and minus 3 over 2, so which is here. So which is here. And we will solve y-intercept as well. X plus 1 cubed and divide 3 on both sides. So that's a cube root of 1 on 2. Well, I can't really find what's cube root of 1 on 2. We'll just make value stay like that. But that's a small value. Like cube root of a half is a very small value. That's a like positive small value. And then we have x equals to 1 on cube root 2 minus 1. Okay, so move the 1 to the left hand side. So it's still minus 1. But cube root 1 is still 1. And then cube root of a half. Cube root of 2 is cube root 2 there. You can times cube root 2 times cube root 2 twice. No, like you can make your answer stay like that. That's like, I think now it's not that a hash on rationalizing denominators, so you can keep like third denominators. But this is a value, it's -1, add a little bit, like so it's -1, add a little bit. So your x-intercept is actually somewhere here, like it's x add a little bit. So the graph looks like this. Okay. Oh, it's like quite stiff. You need to show the point inflection. So, okay, that's better. This one's better. So this is the point of inflection form, which is -1 and 3/2, decreasing shape. And this point here is cube 1 on cube root 2 minus 1 comma 0. And the y-intercept is 0, comma -3/2. Here's a decreasing graph. Okay. All right, everyone. You still have like 30 minutes of this session. You can catch up on what you need to do. For this is exercise A, B, C, D, E. This is exercise E already. We might need to go F and G both exercise tomorrow. So what I want to do in a 30 minutes time, okay, go to page 10 and 11. You're doing a quiz this time, like this one tomorrow, but not the test. Not the test. Test is combined with chapter 7. So it's in the third week of next term. Okay. Yeah, third week. Okay, so everyone, what I want you to do now, and you must do that now, is page 10 and page 11. I want you to factorize all the functions for me. Okay, you don't need to worry about any solving things. You just factorize that for me. You learn how to factorize it. You use the synthetic method to factorize. I will go very fast tomorrow, so if you don't do that, you can't follow me. Okay, factorize page 10 and page 11. There's only 1, 2, 3, 4 questions. There's only 4 questions. Just factorize all those 4 equations, and you can do whatever you need to do. Okay, so that's it for me today, and you can ask me any questions if you need. And 10 and 11, page 10, page 11 is all the equations. Yeah, all the page 10 and 11 equations.